Okay, we're writing a two-column proof that takes this equation, 7y equals 8x minus 14, and we also know that y equals 6, and trying to prove that x is equal to 7. So the first thing we can do, we should always do, is to state what's given to us. It's given to us that 7y equals 8x minus 14, and y equals 6. Those were given, so we say given. Okay? Now, we know the value of y, it's equal to 6. So what we're going to do is we're going to take that original equation, and we're just going to substitute in for y what y is equal to, just like that, and that's substitution. Now we need to simplify this because we need to turn 7 times 6 into a single number. So we're going to rewrite that as 42 and say that's just simplifying. And now we're solving this. How do we solve it? Well, we need to undo what's happening to x, and right now these x's, there's 8 of them, have 14 being subtracted from us. We need to undo that with the inverse operation of plus 14 on both sides. And this is what results. And how did we do that? We used the addition property of equality. We added the same amount, 14, to both sides. Now, further, what's happening to x? It is being multiplied by 8. So we need to undo that with divided by 8. And when we divide both sides by 8, we get 7 is equal to x. That was the division property of equality. Now watch this. This is really important. If we follow this down, and remember, I always tell you, don't just randomly switch the sides of where x is. If x is on the right side, keep it on the right side. Okay? So now they're asking us to prove that x equals 7, and we've got 7 equals x. It seems like that's the same thing, but really there's a rule that says we're allowed to switch sides and it stays equal. And the rule that allows us to switch sides to make it look like x equals 7, which is what they asked us to prove, is that symmetric property of equality where we have the sides switched, but there's that symmetry that still exists. Okay, that's it.